my fifth video of stereochemistry. So in my pharma chemistry YouTube channel, going to discuss about diastereoisomerism. So diastereoisomerism, it is an optical isomerism. So compounds in optical isomerism, compounds have two chiral centers. Two chiral centers means compounds contain two different chiral centers. So compound contain two dissimilar or different chiral centers, so that molecule exists in two more than two stereoisomer form. Diastereomers means so a molecule which have the two dissimilar chiral centers. So due to the two different chiral centers, so its isomer can exist in the more than two stereoisomer form. We will discuss this diastereoisomerism with example. So that is 2,3 dichloropentane. So pentane means 5 carbons. So pentane means 5 carbons. 5 carbons. At 1, 2, 3, 4, 5. So at second and third position, chlorines are attached. So remaining will fill with the hydrogens, CH and CH. So this structure can be written as CH3, CH, Cl, CH, Cl and C2H5. So these second and third carbons are chiral in nature. So they have the central carbon is attached to 4 different groups. So when we write the Fischer projection, so we can explain the diastereoisomerism with the Fischer projection structure for the above compound. So Fischer projection can be written like this: CH3, C at second carbon left side hydrogen, right side chlorine. At the third carbon left side chlorine, right side hydrogen. So at last carbon is a C2H5. So for this carbon, the mirror image will be like this: chlorine left, hydrogen right. At third carbon, hydrogen left, chlorine right. Next C2H5. So this is the first form. Next second form. So from the first structure, so when I change the positions at third carbons, so then I am writing the another form of this first structure. So at third carbon I am reversing the positions of the atoms, C2H5. So this is the third form. So for third form, so I am writing the mirror image: CH3, C, Cl, H and C, Cl, H and C2H5. So here these first 1 and 2 are the enantiomers because they are non-superimposable on mirror images. So enantiomers. So for enantiomers, watch my previous video. So that is fourth video. And these 3 and 4 are enantiomers. So whereas 1 and 3, so these 2 and 2 and 4 So 2 and 4 are diastereomers. So they have the chiral centers. They have the chiral centers, and they can exist in more than 2 stereoisomers form. So they can be exist in 2 stereoisomers form. So simply the isomerism is the, so due to the presence of two different chiral centers, the molecule can be exist in more than 2 stereoisomerism form. So here the compound 2,3 dichloropentane is exist in the 4 stereoisomer forms. So if you observe the 1 and 3, so 1 and 3, so these are the non-mirror images, because the mirror image cannot be because of the second carbon. So this one and this one not forming the mirror images, and they are not superimposable. That means non-superimposable. So when I place the first one on the third one, so there is an non-superimposability takes place at the third carbon. So with the hydrogen and chlorines. So we discuss about diastereoisomer. In the diastereoisomer, so it is a pair of, so diastereoisomers are stereoisomers, pair of stereoisomers which are non-superimposable and non-mirror images of each other. They may optically inactive, even have the chiral center, So diastereoisomers are stereoisomers, so 1 and 3, so they are the stereoisomers which are non-superimposable and non-mirror images. They are optically inactive even though they have the 2 chiral centers. So next we discuss about the properties of these diastereomers. So these come to physical properties. So these diastereomers physical properties are opposite to the enantiomers. So whereas the enantiomers having the different physical properties like melting point and boiling point. So whereas come to diastereomers, these physical properties are so they have the same physical properties. These diastereomers have the different physical properties like melting point and boiling point. So that's why they can be separated by crystallization, chromatography, and distillation. Next, come to chemical properties. So enantiomers have the similar chemical properties, but differ in the rate of reaction. So but come to enantiomers, they have the opposite chemical properties when compared with the enantiomers. So that's why these have the different chemical properties. So next one is effect of diastereomers on PPL light. So in enantiomers, one isomer rotates the PPL light in clockwise and another one rotates the PPL light in opposite direction. So whereas these diastereomer pairs either rotates the PPL light in same direction. That means, so in the above example, so 1 and 3 maybe rotate the PPL towards the right side or towards the left side, any one, or so these pair of isomers rotates the plane polarized in opposite direction. So opposite direction as like of enantiomers. So with this we completed about the diastereomers. I hope all of you understood my video. Diastereomers, so please share to anyone, so it is helpful for who is preparing for MSET and NEET, any kind of competitive entrance exam, and for pharma students. So share in your near and dear group, and please share and like, comment and subscribe my channel for more upcoming videos. Thank you one and all.